Welcome to Code IDX. My name is Terrence Whedon, and I appreciate you taking the time to check out my channel. My job is to simplify the learning path so you can achieve your goal of becoming a software developer. Today, you're going to discover the importance of binary code to a computer program. Every programmer needs to understand how computers work. Taking the time to get familiar with the binary system is going to pay off big as you learn programming concepts. Do not overlook this information, because what I am going to go over in this 3-part tutorial will add a lot of value to helping you get closer to your goal of becoming a computer programmer. Let's get into it, shall we? Before we get into the binary system, let's compare it to a numbering system you are familiar with, and that system is called the decimal number system. Whether you knew that's what it was called or not, you use it daily. If you look at a phone or any number pad, you'll recognize it has 10 digits that represent a quantitative value, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Allow me to introduce a sidebar here for a moment. In later lessons, I will go over arrays. The reason why I'm introducing it now is to point out something that we call indexes. What you are looking at right here is an example of what an array looks like. Don't get caught up in the syntax right now. We'll go over that later. But I just want to be able to prove a point here. Just like in our whole number system that we understand, we know that we have columns and of course we have rows. Remember your timetables years ago? They do it differently now, I'm sure. But you have, right now you're looking at a column of numbers, of whole numbers, from 0 to 9. The reason why we call it the decimal system is because there's actually a decimal and there's numbers in between the whole numbers. And one of the things that we want to make sure we understand about those whole numbers is that we're not going to talk about the decimal, what's on the right of the decimal. We're only going to deal with the whole numbers, and that's everything on the left of the decimal. So think of the decimal as an ending point right now. And 9, 0 is the beginning and 9 is the end of the column. There's nothing that can go past the 9. But the reason why I'm pointing this out to you is because I want you to understand that this information has really been at the recesses of your mind, and I'm bringing it out. I want you to think about this a moment like the Karate Kid. In the Karate Kid movie, Mr. Miyagi was teaching Daniel how karate by giving him what we call chores. Daniel thought it was menial and thought he was wasting his time. But what Mr. Miyagi was doing, using everyday activities to give his body muscle memory, to train his body to be ready to learn the different moves. And this is what I'm doing now, because this information you were taught when you were a child. Sometimes we just forget about it because of life experiences and we've moved on, and sometimes we think it's just trivial now. But this little bit of information that's taking you back to the elementary level is going to open up a new world for you. And remember, and I'll go over it in the next tutorial though, I won't go deep now, but we start at 0, but we're used to starting at 1, but we were actually taught it starts at 0. And so I just want you to jog your memory to get back to that point. I'm shaking your brain a little bit because we need to start thinking in these terms, especially as a computer programmer, because computers are really elementary. they just become very complex because that's the way that we built them, and we've learned how to make them more complex. But it really operates on a very simplistic level when you think about it. So now let me get back to the array. And so here in this array, you see what I have here is 5 numbers: 2, 5, 4, 21, 15, which in arrays we know them as, let me get my pen here, we know them as items. But now in the array in computer science, these items in the array are actually indexed, and they start at 0. This is why I wanted you to see the column and how we're going to count the number. So this 2 is actually an index of 0, and this 5 is at the index of 1. The 4 is at the index of, get that back, sorry. It's at the index of 3, and my pen is acting crazy. And 15 is at the index of 4. Now, this is important information because later, when I teach you about different methods, you would need to understand that the tasks that the methods carry out, for instance, there are methods that return the index, which are these numbers right here. And then there are methods that return the item. This is very confusing for new developers, people that are learning code for the first time, to get their head around this. My approach is to give you a visual as much as possible. So it's very important that you remember this concept because you're going to need it later. Now, let's get back to the counting rule. Now, what I want to do is show you what the counting rule is. And this is something that you're familiar with. You already know this. I'm going to show you how the counting rules applies to decimals. And then I'm going to show you how the same counting rule applies to binary code or numbers. The rules of counting is 1, increase the most right column by 1. And the second part of this is when you run out of digits, reset the column that ran out to 0, increase the next column by 1. So now when we go back over here to our whole numbers, now we're going to start the process and we're going to start counting. One of the most frustrating things about programming is not understanding how the process works. Today, I am going to give you a block. As we go through each lesson, I will give you another block. And these blocks represent the foundation of what you need to know to become a software developer. So now here, we have a whole number. Now, notice that there is a wall right here. It doesn't go below these whole numbers right now. And notice that to the left of the far right number, which it starts with the what we call the ones columns, there are other zeros here that you don't see, but they're there. And just like our counting rule, it tells us to increase, we have to add 1 to the number. So when I add 1 to 0, I get 1. When I add 1 to 1, I get 2. When I add 1 to 2, I get 3, and so forth and so on. But when I get down to 9, and this is important to know and understand, because one of the things that we're going to be dealing with in programming is the end of arrays. Well, 9 is the end of this column. Nothing goes below the end of this column, 9. So when I get to 9 and I try to add 1 to 9, I have to go to the next column. So now let's look at this down here. So down here at 9, I got these 0. I have these extra columns, 1, 2, 3. So really 4. 1, 2, 3, 4. So when I get down here to the bottom of this column, I have to reset. Remember, I have to give it a 0, and then I go to the next column and give it a 1. That makes it 10, because we're using the base 10 system. But really, we don't have a number 10 in the one column. We have only a 9 at the end. So to be able to go to the next column, which is the tens column, that's where I add the 1. And every time now when I add a 1, I add my 1, and then I carry down the 1, because I'm still back into the ones column, and then so forth and so on until I get down to 19. Once I get to 19, and then I want to add 1 to it, now I'm at the end of the column, so I have to reset, add the 0, go up to the next column where 1, now I can add 2. That's where I get 20. This seems to be very simple and straightforward. And like I said, programming computers really is simple. I want you to always look at it in its simplest form, because sometimes we make it so complicated and it gets frustrating. So now I want to go over another sidebar really quick. There are 3 errors that we're going to teach you about, and you need to know them. But the name of these errors is called compile errors, runtime errors, and logic errors. We'll go over these errors later on. The first 2 will give you a message in the console. The last one, which is the logic error, will not give you any messages. It will be up to you to know if the output is correct. So a logic error means that I'm not getting the expected output that I expected to receive. So what does that mean? So let's say I have 2 plus 2. I know the answer is 4. But when I write my computer program, my syntax may be correct. It runs, it does what it's supposed to do. But the answer is 5. I know that's a logic error. That means something in my code is not correct, and I have to fix it. The thing I'm trying to condition you right now to understand is that you are responsible for knowing what the output is. That's why we say that computers are not smart. You have to tell it explicitly what to do. And if you do not tell it explicitly what to do, it's going to give you the wrong information. And you are responsible as a developer to make sure that information is correct. So this is why I'm using this counting system, the counting rule, to help you understand how to count in binary, because this is going to help you down the road. So now let's finally get over and let's count some binary code. Now, understand, a binary system only deals with zeros and ones. It's base 2. It's not base 10. And I'll go a little bit deeper about how we got to this point in the next tutorial. But this right here is very interesting. And because the 0 ones, you're going to be confused at how this works. But I'm going to make it as simple as I can to help you understand how to count in binary. So now let's go back over to our binary code. So first, let me go ahead and erase some of this noise that we have here. And so I'm going to get rid of that, get rid of this, erase this. All right. And then I'm going to leave that 19. And I'm going to leave that, get rid of that 10 right now, because I don't need that. And I'm going to get rid of these zeros. Okay. Now, over in our binary system, we are dealing with zeros and ones only. We don't have base 10. We just have base 2, which I'll explain more. So here, just like the decimal, it starts off with 0, and then there's other columns of zeros. It's important to know this. And again, I will go over this in the next tutorial. But here's another side note or a sidebar. You are taught that this is an equal sign in computer, and you are correct. But in computer science, or as a computer programmer, this is not an equal sign. This is called an assignment operator. It's important for you to understand the terminology. You have to learn the terminology, because if you don't learn the terminology, you're going to be confused. So do not gloss over this. And again, from here on out, do not call it an equal sign. We have something in JavaScript where we use double equals to represent equals. And then we have triple equals to represent strictly equals. So it's important that you understand that now. So call this an assignment operator, not an equal sign. So here we have 0. This is how you say it. 0 is assigned to 0 binary. Now remember, in our counting, right? We have to count. We add 1 to the first column. So to get to 1, we add a 1. So now we can add a 1 because the first number or the first digit is 0. So this 1, and then we have extra zeros here. So this number represents 1. Another thing I want to point out to you, there's no magic here. All of this is a logic. Everything represents something. This binary number is going to be assigned to 0. It's always going to represent 0. This binary number 001 is always going to represent 1, because computers can only read binary code. This is going to work in every language, because in America, I'll go over this in the next chapter or the next video. Letters are assigned to numbers, and those numbers are converted to binary. And I'll show you how that works in the next chapter or the next video, actually. So to get the 2, I got to add 1. So I add 1 to this 1. I'm at the bottom, just like 9. I can't go anywhere, so I have to reset. I reset that, and then I add the 1 in the next column. That's the number 2, and represents the number 2 in binary code. And so now I add a 1, and I can add a 1 now because it's not at the bottom. And then I carry down the 1, and as you recognize, now I have a binary code for 3. So I want to add 1. I can't add 1 to that column anymore, so I have to reset it to 0. I can add 1 to this. I can't add 1 to this column because there's a 1 already there. So I assign that to 0. So now I'm at the next column, which is 1. Well, it looks like 100, but it's the binary code for 4. So with 5, I can add 1 to the 0 column. So 1, I bring down this 0, and I bring down that 1. So now it's 101. But with 6, I have 1. I can't add a 1 to it, so I have to reset it at 0. Add the 1 here, because there's a 0 right there, so I can add the 1. Bring down the 1 in the third column. 7. I can add a 1 to this 0 now. I bring down the 1, and I bring down the other 1. So as you can see here, there's a pattern. That's another thing about programming you're going to discover, is that there's patterns. So now here, when I get to 8, I have to reset the 0. I have to reset the next 1 to 0 because I can't add a 1 there. I can't add the 1 to this one, so I set it to 0. So what do? I add another column. So now for the number 8, it's represented by this binary code. The number 9, I can add a 1. I bring down the 0, I bring down the other 0 and the 1. So that's what 9 is. So now when I finally get down to 10, and remember in decimal, I reset to 0 and I added a 1 to the next column. So here, I can't add a 1 to this column anymore. So it has to be set to 0. I can add a 1 here, and I can carry down this 0 and this 0, this 1. So what does that mean? Now what I have just done, I have just showed you how to convert whole numbers to binary code. Now, I want you to keep counting and go back and review this information and bookmark this video for later review. Now you have your first block to add to your foundational knowledge of software programming. In the next tutorial, I will break down how numbers, letters, and symbols are converted to binary code. If you haven't subscribed yet, please consider doing so. And if this video was helpful, like it, share it on your social media, share it with your friends and family that want to learn programming, because I would teach it at a simple form, and comment. So until next time, happy coding.